It's 11:10. So first of all, thank you everybody for joining us to this roundtable, which is absolutely very interesting topic that we will discuss with our speaker. And before I introduce you to him, please make sure to, if you have any questions, to use the chat function that you will see at the right of your screen, and submit your questions, and we will try our best to answer if time allows us. All right. So well, I want you to introduce you to Matt Roberts from IBM, and I will ask Matt to give us a brief description of his role in IBM. Please, Matt. Thank you.
Sure. Thank you. Thanks, Mariana, for having me on, certainly. So my name is Matt Roberts. I'm the Distinguished Engineer and Chief Technical Officer for the IBM integration portfolio within IBM. So I lead the technical team that covers not just our API management offering, which is obviously what we're focused on here, but also we have other products around app integration, high-speed file transfer, enterprise messaging, and so forth. So I have the pleasure of leading the technical team that delivers all of those various integration products from an IBM perspective.
Very well. Thank you, Matt. So let's move on to some of the questions that we have prepared for this session. So I'd like to start to know how can we host APIs in a closed internet environment?
Mm-hmm. Yeah. So certainly a good question to get started with, kind of easing into the hybrid nature. So actually, this is something we get a lot with our customers, and many API management platforms, including what we provide from IBM, actually provide a range of options for how you would deploy them. So oftentimes in an API management kind of scenario, the APIs that you're exposing perhaps are public to be invoked by mobile applications, but actually the internal use cases are kind of like the iceberg under the water, as it were, in as much as there's often larger number of APIs and higher volume of API invocations inside the enterprise. So products like our API Connect solution from IBM actually provide that option to deploy inside your enterprise as a customer managed, like a software installation, in order to meet those sorts of use cases. And in fact, there's even within that, there's a couple of different variations on deployment styles. One of which is to say, well, I want to expose my APIs internally within the company. All very good, but for example, I'm able to let your software call out to the internet to get security patches and bug fixes and so forth that it can bring down. So that's one of the kind of sub clauses, and the other one, which we actually see a lot with our kind of enterprise larger customers as well, is for a fully disconnected kind of style of deployment. And in that case, there's often a kind of hard wire around the network that says, well, actually, there's no call out at all to the internet or any sorts of external services. So we provide an option for things like a disconnected or an air gap deployment, as we call it, that says, well, let's take the product binaries, have a way of moving those across into the secure network zone. And then once you have those available, you can install our API management solution, and similarly with other offerings, and actually use it entirely within the bounds of that private network arena.
Okay, great. Thank you. Thank you. I thought it was paused, the video. Thank you. Yeah, Matt. So moving on to the next question. How does it take, or how to design APIs in hybrid cloud?
Mm-hmm. Yeah, interesting question. So I'd separate out in this conversation or try and architecturally look at, well, what do we mean by hybrid when we're designing an API? And typically we have a point of enforcement, the API gateway, for example, and then there are back-end microservices or applications that live behind the API facade, which are providing the business service and kind of the data that gets passed back through again. Typically, what we would recommend even in hybrid style deployments is actually to align or to co-locate the kind of data processing pieces of the API. So that generally means having your gateway component of your API management solution close to where the backend microservices are, the backend applications that are running. So even though you might be exposing that API to something which is running in a different network zone or a different region in a kind of hybrid topology, aligning the runtime processing so that all happens in a kind of small scale and contained environment is really good for things like performance and security and availability, because the items that are involved in that kind of core runtime interaction are very closely and kind of tightly bound together. So that then kind of leads on to, well, what does that mean in terms of hybrid? And that's where we talk about things like, well, where are you exposing the API to? Like, is it a consumer that's running in the cloud that's calling back or invoking the gateway that's deployed where the business applications are? And there are some other scenarios that I think we might get into some more details a bit later on, depending on where the questions go on. Well, what does that mean from a deployment perspective? Like, can we meet that use case of having the gateway close to the business applications, while also having some flexibility in terms of where the other components of the system actually run?
Excellent. Thank you, Matt. So now talking about best practices, what are those best practices when interconnecting APIs? Okay.
Yep. Yeah. So a number of different approaches here. So when we think about how we're designing an API, like often there'll be a front end, as I said, perhaps that's the interface to the mobile application or the web application that's consuming the data, and then a network of services in the back end. It's certainly important when we're looking at connecting different APIs together is to understand what the effect is that has on the consumer of the kind of end, or the entry point API, as it were. So in particular, obviously want to be very careful about what the performance profile is. Like if the customer's sat there on a mobile application checking their account balance, for example, with their bank, they're expecting that account balance to come back in a couple of seconds perhaps. So when we're then looking internally about having a network of other APIs that we might connect together, we want to make sure that end-to-end response time, the thing that the consumer sees, really is within their bounds of expectation. And in particular, if we're looking at maybe the difference between an API, which we would invoke synchronously, like get me a set of information very quickly, versus something which might be a bit more long running, either because it has to go further and get more data. That type of thing can have a really significant effect on the experience of the customer, the end user, as it were. So certainly those sorts of things are important when we're looking at chaining APIs together. Typically, the kind of basic pattern is you'd have your fronting API, the thing that the consumer sees, and obviously the application that's invoking that will have security credentials and have permission to invoke that API. And then from a security perspective, we almost act from that point in almost as a system component and say, well, I as this API, I'm going to call the next one down in the chain and use my own credentials to do that, possibly passing context about the user that's invoking the API so that you can get back the account balance or whatever the particular scenario happens to be. But yeah, certainly chaining the security level across those various interconnected APIs. And then the other point that I kind of put in is actually, although the focus here that we're talking about is APIs specifically, there are cases where that interconnection between the fronting API, the thing that the consumer sees, and the various backend services should reasonably be using other types of protocol as well. Not necessarily a REST API, but there are other things that are sensible to be using in particular technology architectures. So things like, do we want to send an event to Kafka, for example? Like, is that the right thing? In which case, using your API management platform or your app integration platform to translate that incoming request from a REST API into a Kafka event or into a message that you would put onto an enterprise messaging platform such as MQ. So the data exchange that goes on in the back end doesn't have to be the same protocol as it is on the front end. And by picking the right sorts of products and the right sorts of technologies, you can interface with a much broader range of back-end systems and also give those systems to react in a way that matches their performance profile. So one of the kind of key use cases for enterprise messaging, for example, is providing a smoothing function that says, well, I don't have to wait synchronously for your response to come back again, or I don't have to have a live thread to be able to invoke your backend. Actually, I can put a message onto a queue, say, and your backend system will pull those things off as fast as it can, and then reply back again, and we convert back into the REST style interface that the external consumer is expecting to see.
Wow. Yeah, I mean, it's definitely a lot of details that need to be taken into account to meet customers' expectations.
Mm-hmm. Yeah.
In seconds, and we talk about seconds.
Yes, absolutely. Yeah, and that kind of end user expectation is only getting shorter and shorter. You can certainly justify that if we know an order processing scenario, if I'm submitting my shopping cart, then I'm okay to take that maybe 3-5 seconds or so. But my attention span is wandering quite quickly, or I'm wondering if it's going to time out. I'm wondering whether I should click the refresh button, and the shorter the latency and the response time is, the better the customer experience. And I saw a statistic today, actually, in the other customer event that I was mentioning. We're running on site in our own location, that an extra second of response time in your API. There was a study by one of the analysts. They'd seen that followed through to something like 15% drop off in order rates. Like they correlated an extra second was enough to get 15% of the consumers to give up and kind of go on and do something else with their life. So the response time piece in particular is critical to make sure that the consumers of the API that you have are getting good service, and they're focused and getting through the workload that they want to drive.
Absolutely. Okay, Matt. So how can we make use of API management SaaS platforms in a hybrid architecture?
Mm-hmm. Yeah, interesting question. So typically in a hybrid kind of topology, a hybrid architecture, we're talking about often some piece of that being an on-premise data center, and the other parts of the hybrid ecosystem are either someone else's data center, maybe a provider that you work with, or a public cloud environment. And one of the great things about the public cloud providers is many of them also have a kind of API management solution, or an API gateway at least, that's in place there. So there are certainly options when you start looking at hybrid architectures to understand what are the components that are available to drive those sorts of behaviors. So you might well have an isolated instance of an on-premise API management solution that's used for delivering certain types of workload, again, focused out of the business applications that are running on-premise. And then if you're also in AWS or Azure, for example, there are managed API platforms that you can make use of. Some of them come from the cloud provider, like AWS as an example. There are also vendor platforms as well. So I'll put a quick plug that we recently announced in the last few days, an API Connect SaaS offering running in AWS. So that's providing that full lifecycle management in an API API Connect form factor, but running in AWS for our customers that have their business applications running in those sorts of environments. And whether you're looking at a vendor solution like IBM's, or the AWS native API gateway, which is a kind of gateway piece rather than a full lifecycle management area, those managed platforms can help to reduce the amount of work and the amount of responsibility that you as a customer have to take on, because pieces of the platform are managed for you by the provider. So in a kind of full SaaS case, things like how do I create my API? How do I deploy that into the gateway? What is the kind of gateway fulfillment aspect of that? That's all the infrastructure and the availability is all managed by the provider for you. And that leaves you to focus on, well, what is it that I want to achieve as an API developer, as a provider of the particular API. In fact, there are also cases where those managed platforms can actually extend down into other environments as well. So one of the scenarios we see with our customers is about having a managed control plane, so the kind of API manager side of things, the API developer piece, but actually enabling that platform, that control plane to deploy into a gateway which is running maybe on-premise, in order to put that gateway close to where the application is. And in that kind of split deployment model, control plane in the public cloud managed by the provider, gateway on-premise typically managed by the user, by the customer, that helps to delegate a lot of the responsibility to the services provider, the SaaS provider, while maintaining that ability to keep the gateway close to where those business applications are. So it can provide a good hybrid middle ground between having to run everything yourself versus having to have everything in the cloud.
Yeah, exactly. Well, excellent. So the next question is, how does network connectivity work between locations in a hybrid cloud architecture?
Yep. Yeah, so again, in the kind of topology we have in mind here is typically some piece of environment on-premise, some piece of environment in a public cloud provider, AWS, Azure, or IBM, Google, so on and so forth. And the interesting part about the networking connectivity is to understand, well, what are the relationships between those different environments? So I talked earlier on, like the ideal case is to have at least the gateway close to where the applications are, the kind of business applications that we're fronting. In some cases, you may have a more complex relationship between the external API facade that's being invoked by the consumers and wherever the backend services are kind of running. So in terms of how do I get from perhaps a microservice running in the public cloud that needs to consume data that's running on premise, a number of ways that we can do that from an architectural perspective, often using capabilities provided by either the cloud provider or your own kind of on-premises networking team. So in the very simplest case, kind of lightweight, easy to set up, you might use a TLS encrypted channel to navigate across the public internet. So some endpoint that exists on premise that you want to provide as the backing piece or providing a data service for your API. Very easy to call out from your cloud provider's environment, your deployed application there, down to on-premise. Not necessarily very performant because it's over the public internet in that case. Security middling because you can configure mutual TLS to protect the data that's going across. But still, you have data is being transmitted across the kind of public backbone of the internet. So that's something that, particularly with regulated data in many industries, that's something we want to avoid. So then you move into a situation which is something like an AWS Direct Link, which is a kind of hardline tethered connection, private backbone between your data center and what the cloud provider as AWS or equivalently in the Azure case provide. So that provides a lower latency, higher security mechanism for bridging between two different network zones. And then kind of in the middle, if you like, there's some technologies around VPN and IPsec, which are tunneling over typically the public backbone that help to mitigate some of the security concerns, but still have that concern about latency and the variability of speed over the public backbone.
Very well, very well. So now we would like to know, is it better to use a different API management solution in each provider or the same one everywhere?
Oh, that's a big question. So there are pros and cons to each. I guess I would say, as often with these things, it's kind of it depends sort of answer. The advantages, I can take them in order. The advantages of using the same solution across all your different platforms is obviously one of consistency. So various products, including what we provide from IBM, they have a hybrid deployment capability that says, well, I can deploy on-premise, I can also deploy in AWS or in Azure, either as a software solution that I manage myself as the user, or as we were saying, maybe as a managed service in some form that's provided by the kind of service provider. The benefit there is you can actually take exactly the same API artifacts, the same description of the API, the same wrappering and security controls and so forth, and you could choose to deploy that very easily, either on-premise or in a public cloud. Your CI/CD pipeline, for example, can drive exactly the same process with the same artifacts, just to different endpoints, effectively. So by using that same solution in all the different locations, you get consistency. You only have to write things once, and it enables you to be more agile and drive more quickly. Conversely, if I look at it from the flip side, there are benefits in using a provider's own solution in some cases. So I'll use AWS as an example, as we're doing a lot of work with AWS and IBM at the moment. The AWS API gateway has obviously great built-in integration with the rest of the API platform, rest of the AWS platform, as I say. So if you're already using things like CloudWatch for monitoring and alerting, then the API gateway helps to plug into that, or auditing in CloudTrail as well. So the service integration between the provider's API platform and the rest of the ecosystem is all very good. The downside, obviously, is that looks completely different, whether you're in AWS or you're in Azure or you're in Google. So if you have a multi-cloud strategy, or you need to bridge out across different clouds, then that effectively is a re-implementation activity that you need to do in each of the different environments that you want to be part of.
Yeah, very, very interesting topics, Matt. Thank you. So another question, we still have a few minutes. So how do burst to cloud scenarios work?
Okay.
Can you tell us about
Yeah, this is an interesting one. So we often, from an IBM perspective, we often hear customers talking about, I want to burst to cloud. And actually what we're seeing is a number of different scenarios that are actually behind that type of conversation. One of the things, so typically it's about, I want to have either additional capacity. So I have a certain amount often on premise as my kind of base environment. I'm coming up to Black Friday. I'm expecting a spike in traffic. How can I leverage the elasticity and the kind of flexible pricing of a cloud-based deployment to provide that additional capacity? So that's one reason. Another path is sometimes in terms of resilience and availability. So how can I use a second environment which is completely unrelated to my primary environment in order to provide failover effectively? So if my first environment goes down, has a problem, data center gets powered out or something, how can I use a secondary deployment somewhere else in order to carry on serving my end user customers? And I think actually in both those two cases, the key thing is to focus not just on the kind of API gateway and the kind of related things, maybe the developer portal and how you kind of manage that API. Doing that in isolation, yes, it's relatively easy to put a new gateway somewhere separate, either with the provider's service or with a kind of hybrid deployment model. But actually, you have to consider the whole end-to-end solution in order to be successful. So, for example, putting an API gateway into Azure, pick Azure this time around, as the endpoint to serve data, it is great as long as you're not kind of calling straight back down to the on-premise network to get the actual business data. So if the business application that you're putting in place or that you're talking to is only on-premise, then having this gateway running in the cloud really isn't saving you anything, because if the on-premise data center is offline, then all the back-end services have gone out anyway. So the cases where we're seeing customers be successful with a kind of burst to cloud model is actually where they have the ability to also replicate the back-end microservices, the back-end applications into that separate environment as well. So that lends itself to either kind of replicatable data, like a read-only model that says, well, I'll synchronize data off on a regular basis to this secondary environment so that it can serve API requests independently if it wants to, or some mechanism where there is a level of sufficient synchronization between the two that you can come and go and still independently serve that traffic. So certainly if you're hearing questions from either your business team or other folks about burst to cloud, it's really important to cover not just the entry point, but also the whole end-to-end solution. Ooh. I think we've lost Mariana. Can anybody else hear me still? Post a message in the chat if you can hear me. Okay, cool. Yeah, I'm still here and still on audio. Yeah, so as certainly I can't hear Mariana, but very much thank you for everyone for joining. Great to get the chance to talk through some questions with you. I don't know whether I'm allowed to stick around and answer questions in the chat afterwards, but I'll certainly be in the main area chat if folks want to connect up. Okay, perfect. So I see Ranjan's question: does IBM have a roadmap to implement hybrid deployment model of API Connect? So yes, is the short answer. So we actually do this already. We have a single tenant deployment of API Connect called reserved instance, and in that case, the control plane runs in IBM Cloud currently today. Possibly that will move to other clouds in future. And that provides the API manager and the analytics and the developer portal pieces of our API management solution. and there's an option for customers to have remote gateways that they manage, perhaps on premise or in other cloud providers that are tethered back to that managed control plane. So that's really good, as I was saying, to delegate 3 out of 4 subsystems to us as IBM to manage on your behalf, but also to have that flexibility to keep the gateway close to where the business endpoints, business applications are actually running. Oh, yeah, you're back.
Oh my God, I'm sorry. I don't know what went wrong. My internet is working, so I don't know. Well, I don't know if you were able to answer to Ranjan's question. If you did, I think our time is up now, and only thank you so much. Sorry for this pause, but thank you so much, Matt, for your insights, sharing your insights, your knowledge, and thank you to the audience. And again, we invite the audience to visit our partners village and obviously to join us in the next roundtables throughout the day. So thank you, everybody. And Matt, especially you, thank you so much.
Yep. Thanks, everyone. Bye for now.
Bye-bye.